Let's continue with question 7 for P3 paper 2014 May and June version. So look at the question. The straight line has equation R and the plane passes through the point and is perpendicular to the straight line L. So first of all, R represents the equation of a straight line in vector form. Okay, you see, first of all, there's the first part which represents a fixed point. Okay, so there's lambda, which is a scalar. Then the second part is another vector which represents the direction of the straight line. So you see, R actually is a position vector representing a certain point on the equation of the straight line. So this equation represents the straight line in vector form. A fixed point, a scalar. The second part is another vector which represents the direction of the straight line. So let's look at page 161 in the textbook. Right? R is the position vector representing a certain point on the straight line. So the first part representing a fixed point. The second part represents the direction of the straight line. So these two parts add up together, it becomes the position vector of a certain point on the straight line. That is R. So R in vector form can represent the equation of a straight line. So from the equation of P, that is the plane, giving your answer in the form AX plus BY plus CZ equals D. So first of all, the second part, as I mentioned before, it represents the direction of the straight line, which is perpendicular to the plane P, or we call it, it is normal to the plane P. It represents the direction of the straight line, which is normal to the plane P. So that's why the equation of plane P can be expressed in this form. Get back to your textbook on page 161. Okay, so we can tell the equation of the plane can be expressed in this form. As P passes through the point which is given, then we're able to find out the value of K. Put the value of K back to the equation, then we're able to find out the equation of the required plane in this form. If you forget about this theory, get back to your textbook 161. There's a theory that we can express the plane in this form. So part 2. Find the perpendicular distance from the origin to P, to the plane P. So there are several methods to solve this problem. So first of all, we can use the formula, which represents the distance from a fixed point to a plane. Okay, the equation of plane, we have A, B, C, D as the constants or the coefficients. Okay, the standard form of a plane and a fixed point. So we can use the formula to calculate the distance from a fixed point to a plane. put all the coefficients of the plan into the formula. X log, Y log, Z log represents the fixed point. So the question asks us about the distance from the origin. So that's why X log, Y log, Z log equals 0. So the numerator remains D only. Okay? And we can put ABC into the formula. Then we are able to find out the required distance. Okay? We may use the formula first of all. Or we can use another method. We suppose R is the position vector from the origin to the plane P. So that's why R is in this form, because from the equation of straight line, the fixed point, that is the starting point, is origin. So that's why the first part of the equation, the first part, the fixed point, is all equals 0. Okay, because it starts from the origin, it all equals 0. Only the second part remains. So we suppose R to be the vector representing the distance from the origin to the plane. So R can be represented in this form with unknown mu. So because the point is located on the plane, so we put 2 mu into the equation of the plane. We put -3 mu into the equation and 6 mu into the equation. It satisfies the equation of our plane because this position factor represents the perpendicular distance from the origin to the plane. So that's why this point satisfies the equation of the plane, because the point is located on the plane P. Then we're able to find out mu, and then put mu back to the position vector, and then we're able to find out the required perpendicular distance. Part C. The second plane Q is parallel to P, and the perpendicular distance between P and Q is 14 units. Find the possible equations of Q. So, as I mentioned in part 2, P can be expressed in this form. So, that is the reason why Q can also be represented in this form. Okay? There's a theorem in the textbook, page 161. Okay? So, the simplest way to solve this question is to use the formula representing the distance from a fixed point to a plane. So we calculate the answer 23/7 from part 2. Q can also be expressed in this form. This is the D. This is the D for the equation of Q. So by using the formula K/7, it represents the distance from origin to Q, distance from origin to P, minus distance from origin to Q. It means the difference between the distance P and Q, which equals 14. So we're able to find out the possible values of K, then put it back into the equation. That means we're able to find out the possible equation for plane Q. So these two are the possible equations for plane Q. Okay, let's look at question 8. sketch each of the graph cosecant x and x bracket pi minus x, show that the equation has exactly two real roots in the interval. So first of all, as required by the question, we need to sketch both of the curve. You see here. Cosecant x, okay? We sketch the curve in the interval from 0 to pi. Y equals cosecant x. You may get back to your textbook, page 66, about the graph of trigonometry. It looks like a parabola for cosecant x with a minimum point 1, okay, and asymptotes. So this point is important. The minimum point 1 is important. So y equals cosecant x. So another graph is a parabola which opens downwards because the coefficient of x squared is minus 1. It means that the parabola opens downward, or we call it is concave down. For the slope is decreasing, we can call it is concave down. And there's a maximum point, x squared by 4, which happens at x equals pi over 2 because it is symmetric. The parabola is symmetric about x equals pi over 2. So these two are the graph of the given function, part A. So you see there are exactly two points of intersections. So you have to clearly sketch the graph to show there are exactly 2 points of intersection. To show that this equation has exactly 2 real roots in the interval from 0 to pi. Okay? This equation, the solution of this equation is represented by the two intersections of the two graphs. So you have to clearly sketch the graph to demonstrate it. And part 2 show that the equation can be written in the form, okay, 2 marks. So it is not hard to work on it. Cosecant x means the reciprocal of psi x, reciprocal. The reciprocal of psi x. And then the right hand side. So we arrange the expression a little bit. Then we're able to put x as a subject on the left hand side to prove the statement. Two marks. And then part 3. The two real roots of the equation are denoted by alpha and beta, alpha less than beta. A. Use the iterative formula to find alpha in 2 decimal places for each iteration to 4 decimal places. So for iteration, we have to get back to the textbook on page 112. Okay, get back to your textbook. So from part 1, first of all, we need to roughly estimate alpha. You see here. The maximum point happens at x equals pi over 2. So this point of intersection, it is alpha. This is alpha. It's roughly around 0.8. So it's 0.8. And then try the process, and then we're able to find out x2. So the question asks us the result of each iteration to 4 decimal places. You see? So I write down 4 decimal places here. 4 decimal places here. So when we got x2, put it back in the formula to generate x3, x4, and x5. So you see both x2, x3, x4, x5. If we correct the answer in 2 decimal places, it can tell alpha equals 0.66, 0.66. Okay? If we correct the answer into 2 decimal places, we can tell alpha equals 0.66. That is alpha. So part B, about beta. This one is alpha. This one is beta. The x-coordinates of the intersection. So by symmetry, because the parabola is symmetrical about the axis of symmetry. So by symmetry, we can tell beta equals 2.48. Pi over 2 is just the axis of symmetry, and then plus this part. Then we can tell beta equals pi over 2 plus the second part. Then we're able to tell the answer, 2.48. That is alpha and beta for question 8, A and B. So question 9, partial fractions. Express the expression in partial fraction. So from your textbook, 203, we can rewrite the expression in this form. We call it partial fraction. Okay. The denominator of the first term, the degree is degree 1. The second one is degree 1. The third one is degree 2. Okay, which is standard form for this expression to be written in partial fraction. So the numerator is a constant for this one, the second one, and the third one. So there are 3 constants we need to determine. So we write the right-hand side and comparing the corresponding coefficients. Equation 1 means the coefficient of x squared equals 1. We call it comparing the corresponding coefficients for the coefficients of x squared. Second part, for the coefficient of x, you see, 12 equals the sum of the coefficients for x. And all the constant terms add up together, it becomes 4. Then we're able to find out ABC. Put it back into the formula. That's why we can express the expression in partial fractions in this form. That is part 1. And then part 2. Hence, always when we see the word hence, it means that we must use the result obtained from part A. Obtain the expression in ascending powers. Ascending means increasing, okay? Increasing, that means from constant to x squared, and x to the power 3, x to the power 4. Ascending powers means increasing, up to and including the terms x squared. So from binomial series on page 190, okay? Look at the binomial series on page 190. We can re-express each of the terms that we obtained in part 1, okay? We can express, okay, this one bracket -1 power to -1. By using the binomial series, we can expand the terms one by one, as required by the question, up to x squared in ascending powers, 1 x squared. That is the first part. For the second part, expand it by using the binomial series. Constant x up to x squared. And then the third one, expand it by using the binomial series. So the question asks us to find out, to expand this expression in ascending powers up to x squared. So from part A, we express the required expression in this form, and then expand it one by one, and then group it together. The constant for the first part, the constant for the second part, and the third part added up together. It becomes 4 by 3. And the terms for x in the first part, the second part, and the third part add up together. It becomes -8 by 9 x, and the terms x squared. First part, second part, and the third part added up together. It becomes x squared by 27. So that's how we express the required expression, first of all into partial fraction, and then by binomial series, group all the terms together up to x squared, arrange it in ascending powers, okay, from constant to x squared, including the terms x squared. That is part 2 for question 9. Okay, question 10. The diagram shows the curve, stationary points. Stationary points means f pi x equals 0. For those points which satisfy this relation, f pi x equals 0, we call it stationary points. In Chinese, 它瞬间停顿了一下，静止了一下。Okay, T1, T2, T3， 停顿了一下，突然停顿了一下。f pi x equals 0, T1, T2, T3. Find the x coordinates of T1, T2. So we need to differentiate the function, finding dy by dx, and finding the x values which satisfy the requirement for stationary points. First of all, differentiation. We use product rule and chain rule. Okay. The second part, hold it as constant. Differentiate the first part. Differentiate this part. Differentiate EFX. It becomes EFX. And then we need to differentiate the power as well. Differentiate the power with respect to x. That is chain rule. We call it chain rule. Plus the first part, hold it as constant. Differentiate the second part. Okay, as a whole, it is product rule. Differentiate sine 4x becomes cosine 4x. So by chain rule, there's a 4 here. Differentiate 4x with respect to x. We have a 4 here. Okay, for stationary points, dy by dx equals 0, which gives us this expression. Okay, we rearrange the statement only the expression inside bracket equals 0. So that's why we move on here. Okay, sine 4x divided by cosine 4x, it is tangent 4x. So there are many solutions because there's no restriction for x. But we are asked to find out the x coordinates of T1 and T2. And T1 and T2 is the first and the second solution. The first and the second solutions. So that's why we're going to pick up by arctangent. We can able to find out x, the first one and the second one. That is the x coordinate for T1. That is the x coordinates for T2. And part 2 asks us to find out the least possible value of n given the x coordinates is greater than 25. So from the graph, we observe that the difference for all the x code for T1 and T2, T2 and T3, T3 and T4, the difference of x coordinates is only differ by pi over 4. Only differ by pi over 4. You see? X coordinate of T2 by T1 and then T3, T4. Only differ by pi over 4. The difference is only by pi over 4. So Tn, that's why we can express Tn in this form. That is Tn. For Tn is greater than 25. Tn is greater than 25. So we can express Tn in this form, greater than 25. From T1 and then plus n minus 1 pi over 4. Pi over 4 is the interval. T1 plus n minus 1, the interval. That is Tn. It looks like the common difference. Okay, first term plus n minus 1 common difference. It looks like AP. N is greater than this one, and then calculate the answer. N must be greater than 32.4. So the least possible value of n is equal to 33. That is part 2 for question 10. So we finished all the 10 questions for P3 paper 2014 May and June version. Thank you very much.